Hello fellow Haskellers and welcome to Giggles is You! Today I'm streaming to you from a slightly weird angle because my cat barfed on my keyboard, which is now dead, and so I had to rearrange my setup so that I can type on something. And so I'm typing on the laptop, which is usually here for the regular angle, so slightly different angle this time. Anyway, please ask your questions anyway. Otherwise, if there are no questions, what I plan to do today is to, well, add the quintessential feature of Baba Is You to Giggles Is You, which is already what I said I would do last time, but last time I only did the parsing portion. If I push is in between sheets and you, I form the sentence sheets is you, and so I will now expect to be able to control the character sheets here in addition to the character giggles. It's not currently the case, even though I did write the code to parse the sequence of words sheets is you into the rule. The rule name is you sheets name, which now, when I enable it, I can indeed control those characters. And so all that is needed in order for the magic to happen is to parse. Well, I have to run the parser, but now I need to call the parser, right? I need to iterate through all of the cells to see if there is a sequence which parses as a rule. So let's try that. Okay, so last time we tested the parser using a unit test, where we were able to parse a sentence such as, in this case, sheets is stop into name is stop sheets. And how did we do that? The definition of check parser we called early.full parses. So let's call that from the main loop whenever we move. So what happens when we move? React UI. I'm reacting to a bunch of special characters and otherwise delegating to React World, and then React World reacts to keys, and then that moves the level according to the move view function. And I think after that I want to add another where did I put it? I thought I had put in my keyboard this line, full parses. I want to call full parses, well, probably not directly here, probably like from a function that I call here. So maybe update rules. Something like that. Oh no, because this is updating the level, but not the rules. Is it? Like, world, what does world contain? Yeah, it contains the level and the rules. So I want to update the levels. LVL prime, the new level, or there's no LVL without the prime. So, okay, level prime is going to be this. And W updated with the level is level prime, and the rules is rules prime, which I will compute from the new state of the level after I have pushed the blocks. So detect rules in level prime, and I don't need to give it the old set of rules because I think I'll clear out all of the rules that are not already present. Well, I will clear out all of the rules, whether they are present in the level or not, and I will just replace the rules with whatever sentences are formed. which I now realize will immediately break the game. Because in the level as designed, we do not have that rule. I mean, the giggles is you rule, so I won't be able to move giggles in order to push the is block in between. So in the main here, I initialize the set of rules to be name is you, name is stop, well, giggles is you, text is stop, which is technically necessary, and text is push. So instead of initializing it here and having it immediately, having both of those rules immediately disappear as soon as I move, I will add those rules to the world. Let's see. So here I guess I can call detect rules on level 1, and that should produce this as well. Okay. And now in the level I want to put somewhere, let's say here on the side, that giggles is you and that text is, oh, there's not enough room, so I guess I'll do that at the bottom. Well, I can do one vertically and one horizontally. This way I can test that I can detect since this is both vertically and horizontally. So giggles is you and text is push. So, oh, I can't show you what the level looks like now because I left things in a state that doesn't compile. So I need to add detect rules somewhere, presumably in rules. I have a new function, probably at the end. Yeah. Detect rules, which takes a level and produces a set of rules. And since I just want to make things compile for now, let's return the empty set. Set of rules singular. Qualified import of data that set is redundant. Fine. Now I no longer import it, so it's no longer redundant. Okay, so let's run the code so that I can show you what the level looks like. Okay, so I've added giggles is you and text is push, but I can't move because I said that I want to return the empty set, no rules. So like if I were to return set the thing that I have in my clipboard, no, I again did not copy the thing I thought I had copied. But the thing I deleted here, if I had this, then I would be able to move. Come on, did I not copy it? Okay. If I align it like that. Wait, what? B is you, that's not what I want. Oh, those were the rules, like, because I did git diff, so it showed me the rules as they were in my last commit and not before I just deleted them from the other file. So I know that what I want is giggles is you and text is push. In any case, I can now move and push the text, and in order to make this edit test cycle shorter than running the game, I will take advantage of my test framework and add a new test for detect rules test, or I guess rule detection test would be a better name for it. Rule detection test is one in which I do exactly what I'm doing in main. I call detect rules on level 1, and I expect it to be something. Well, I added equals is due and text is push, so I expect that to be set.from list. Well, the thing I just hard-coded here. So if I successfully do that, then I'm done. And this is where the fact that I'm using my homegrown test framework instead of HSpec or Tasty is biting me, because I can't just use a built-in that checks that the two are the same, and if they aren't, it prints a nice error message. I have to do it myself. So let expected be that thing. And actual be that thing if expected is the same when expected is not the same as actual, then I'll complain. Did I put to str standard error before? Yes, I did. So let's do that here too, and then fail with exit failure. Okay. So I want to write expected. I guess I can just use show and actual. What is, oh, it's just an indentation thing. Okay, and I need to import level 1, which I think is in assets. Excellent. So I ran the test and it passed, and that's because I have hard-coded the correct result. But if I do mentally again, then it complains. And you see, instant feedback, much better. Okay, so let's look at the level. Well, actually, let's do the same thing as we did for move view, because if you remember, because we've done, I went over this function several times in the previous episodes. We're going through all of the cells from left to right or from right to left, we decide, in order to well, group into chunks that move, but that's not important right now. The important part is that we are iterating over every row from left to right, and we can also iterate over every column from top to bottom or from bottom to top if we want. In this case, I want to do like Baba is you and only allow sentences that are spelled from left to right or from top to bottom, but not from right to left or from bottom to top. So how did we in MoveView iterate over all this? It's with directed level indices. Okay, let's use that. So I want to do something with directed level indices, and the direction in which I was going was the opposite direction of the direction in which the player asked to move. Here I am interested in doing it for two different directions. So let's use it as a variable. Do something to combine them, and I'll get my directions. I want them to be towards the right, so east, and towards the bottom, so south. Okay. And for each of them I'll do something. So directed level indices, that gives me a list. Oh, for the level I need to give a name of the okay. So if we go to the definition, that gives me a list of cell paths. That is, if I give a right, for example, it will give me a list of rows, each of which is a list of cell paths ordered from left to right. So I guess row, so this is a list of rows, so I'm iterating over each of them, so I'm binding a variable called row, and so within this row I want to use my grammar to go from left to right and get all of the possible parses, which is exactly... Do I have that in my clipboard? Still not. Okay. I'm having clipboard issues today. I guess I forget how to use Vim properly. In asset setting? No, in the test, full parses. And back in test setting? No, in rules. Okay, I want to call full parses. And it will give me something. So I have a list of something here that I want to combine somehow. On the input, what is the input? It's the, but it's not necessarily the row, because the row, what is the row? It's, let's go back to the definition of directed dependencies, then the definition of self bus. Oh, it's just positions. Okay. So in order to do anything, I must get whatever the grammar was expecting. It's expecting words. Okay, so I have work to do here. Okay. I need a function which will extract the words. Let's see. So the input is going to be the result of like calling get words, get word on each position in the row. So get word is going to be from cell pos to, well, it can't be from word because there isn't going to be a word in every cell. So it has to be get words. But now the problem is that input does not have the type list of word, because we're mapping over a list, a function that returns a list of words. So we're going to have a list of words, which is not good. Yeah, like it is possible to have more than one like entity on top of each other in the same cell. So in fact, in BabaIsView there are some puzzles that are based on that. Yeah, so I can construct wall is push, wall is stop. But if I want to construct both, I can do wall is and then have push and stop on top of each other on the same cell, and then I can form both sentences. So, well, I'm slightly concerned that like if I have a whole bunch of cells that all have multiple words, then it's going to be exponential to iterate over all of the possible combinations of words. And like I specifically used Erlang because I didn't want exponential parsing. Maybe I can switch my grammar so that it takes a list of words. This is annoying. Oh, I'm already in the listman app. So if I don't care about the performance, I can now iterate over all. It's not all the permutations. It's something else. But I think it's sequence A. Yeah. Okay. Words list. The input, each possible input can be obtained from words list, because words list is going to be a list of words. Sequence A allows me to take a list of effectful computations, which I do have. I have a list of lists. So if I interpret each of the inner lists as a non-deterministic computation that says pick one of those words, then I can construct, using sequence A, like all of the possible combinations. If I have wall and giggles like on top of each other, and then just the word is, and then push and stop on top of each other, I can construct both. Wall is push, wall is stop, giggles is push, and giggles is stop. I now realize, though, that there are some cells in which there are 0 words. Man, this is harder than I thought. Okay. Like, I just want it to work, and I'm not currently caring about performance. I will improve it later. I thought that sequence A would allow me to do that, but it does not look like it does. Okay. I know I said that one of the great big benefits of Erle was that I didn't have to like treat sequences of 3 words especially. Well, I didn't really say that. I alluded to it in the previous episode. It's because I want to be able to deal with, in the future, more complex sentences, such as giggles on grass is you. And that is a sentence with more than 3 words. And parsers are very good at recognizing this form of complex sentence. I could probably even have giggle on grass on wall is you, that was the word. For right now, I think I want to special case to sequences of length 3, so that now that I have my words list, so I have a list of all of the cells that have already been converted, or maybe like the row at the row level is probably going to be easier, like 3 cells can be obtained by iterating over all of the. I can zip row with drop 1 row and drop 2 row. That will give me lists of 3 tuples. Is that the best way to do it? Because now I have to convert the 3 tuple back into a list. So, okay. What if I think there's inits, which is a relevant function here. So what I'm trying to do, I have a list of rows. I want all, like a sliding window of length 3 all the way through, which sounds like a useful function in general. I can define that at the top level. Windows of length n through a list of that of any length. It will give me a list of lists of length 3. So how can I implement that function? So inits, I think, is relevant. Let's look at the example. Nope. Tails? Yes. So here I'm having something. I'm having everything. Here it just so happens that ABC has 3 letters. But let's suppose I'm interested in all, like a window of length 2. So I want AB and BC. Then this first entry begins with AB, and this second entry begins with BC, and this entry doesn't have enough characters, and that's how I know when to stop. So if I use tails, and then I'll have, okay, so one way in which I like to write those complicated functions is by writing comments with an example in between the functions which do the transformations. And I like to do it from top to bottom. And so in order to do that, I need to import control.category then, so that I can write it. This is just function composition, but where if I have f.g applied to x, it means that I apply a g to x and then f to the result. But what I want now is the opposite. I want to apply f to the input and then g to the output of that, just so that I can read what happens from top to bottom in the code. So at the beginning, thus I have something as an example. I can use this as an example, I guess. And then after tails, I have that. And then after that, I want to do take 2 on each of them. Is there a kind of take 2 that returns a maybe, perhaps? Because now, after that, I will have filtered it down so that AB and BC that I'm interested in are both included. But I also have C and empty list that I'm not interested in. And I could now do like filter that I keep those for which the length, oh, not take 2, take n. The length is n, and that will work. To drop those 2, it's just a little bit unfortunate to have to like retraverse it again, because take 2 have to traverse it. So let's see. Hugo. So take has type int, int to list of a, to list of a. I want maybe list of a. Is there a function? Whoa, what happened here? Is there a function with that type? Okay, so the safe package has a function called take exact may. With that type signature, what's the semantics? No semantics. If we look at the code, maybe it will be clear. Well, it depends on the semantic of split at exact. Maybe I can just try it and see if it's the behavior that I want. So in the save package, if I add it to my package that I want, my dependencies, and then I use GHCI so that I can play with it. And it's from save.exact. It's all mangled because I typed too early. I typed import safe.exact, and now I guess I have to wait for safe to be compiled. So I want to try take exact may. Two of, well, actually I can call map of take exact may 2 on a variety of inputs and see what happens in all of those cases. So yeah, it's what I want. When there are that many characters or more, then it takes them. I was slightly worried that it's called exact and that like at least that it would return nothing if the input is ABC or something like that. All right. So here I can take exact may from, what's it called again? Save.exact. And now I'll have just nothing and nothing, and I can use cat maybes in order to only keep the justs. Let's scope early, so I need to import early. And I have not yet implemented get words. Yeah, so here I want windows of length 3 on the row, and for each set of 3 cells I want to get the words, and then I'll call sequence A to get an input, and then finally I can call full parses. Oof! I expected it to be a lot more straightforward. Okay, so I have a cell position, and I think I have a way to get the contents of that cell, sprites at level. So sprites at the first argument is level, and then p, and well, that will give me a list of entities, not necessarily a list of words, but I can let's see, I think I again won't use list comprehension syntax. Okay, so that gives me a list of entities. Well, it gives me a list of entities, so I'm matching on a single entity. But here's a cool trick. So entity, as I just said, has 2 constructors. Let's look at them again. Object and text. And I can match here on one of the constructors, and this makes us to the word, and I can return it. Once again, like in the last episode, I need to hide the meaning of the word word, which means like a 32-bit word, as opposed to a word as part of a sentence. Okay, and tails is part of the list. Cat maybes, I think is either maybe or the list. Maybe. And there's a hole on 148 because this will give me a list of something. Right. Okay, so let's keep going. So each of the full parses is going to give me a pair of a list of all of the possibilities that were parsed. So rules, plural. I want a rule here, so I'll have to also iterate over all of those rules. But I'll only want to succeed if well, I only want to include the rules where I have parsed correctly, which well, I could look at the rest of the report in order to figure that out, like I did in test. here I checked if there were any unconsumed characters. But if there are unconsumed characters, then it wouldn't be returning any successfully parsed outputs, I don't think. So I don't think I need to bother. It would just rule to the empty list, and so this will not iterate over any rules. And I want to make this a little bit less of a long line. Okay, so yeah, I was thinking that maybe I would do the same thing here as I did here to like match on the small subset of values that I care about, using something like report, something, empty list or something, in order to use the list comprehension notation to indicate that I want to narrow my focus on the constructors, so like here, the text constructor, and I want to just ignore the rest. Which is a nice thing that I can do in the list comprehension notation, and which I can also do in do notation, and if I'm using the list monad, it will have the same meaning, and that's good, because the do notation is, I think, more... Is it more expressive than list comprehension? No, I think it's the same. No, it's more expressive. But anyway, what I want to talk about is the fact that, unfortunately, that syntax, like pattern matching on a specific constructor, is also allowed in other monads than list, for which it makes sense to just drop the values we don't care about. And unfortunately, that can lead to throwing an exception. That's what the fail method of the monad type class does. It is a function which, given a string describing the fact that the value did not match, let me just show you in the REPL. Again. Can I? Yeah, I think I can. GCI. Even though it doesn't type check, I think it will still let me use the REPL. So here's what I wanted to talk about. If I use the list comprehension notation, I'll put something here, to match on, say, all of the justs, I can implement my own version of cat maybe, in, say, the list consisting of just A, nothing, just B, and I want to return the X. So I can extract the A and the B from this list. And that's very useful, and I said that I can do the same using do notation. So do just X list, and then pure X, same result. And that is using the fail method. And well, for list, fail of just any string of type list of anything. Let's say int to make it clear that this has nothing to do with the string, the input string. It always returns the empty list. And similarly, for maybe, maybe of again anything, it returns always the same value, nothing. Well, again, this works with the do notation for maybe. If I want to restrict my attention to those cases where I match successfully. Now, unfortunately, fail can also do something with the string. It doesn't have to ignore it and return a constant value. For example, if I call oops in IO, then it throws an exception. And I find that very unfortunate because the monad fail proposal, which introduced this type class, because before the fail method was part of the monad type class. There was bind and then and return, but also fail, and now there's only bind, then, and return, and fail is now in monad fail. And what this enables is to have some type classes which do not, not some type classes, some type constructors which have a monad instance but do not have a monad fail instance. You can't have a monad fail instance but not a monad instance because of this superclass construct. So for example, either, if I do fail of either int, then I can't write that because there is no monad fail instance for either, and that is useful because I might mistakenly believe if I write do something similar than before. I want to match on the justs, but here it can't be a list because the side effect is either, so it has to be something like matching on right of well, nothing, because I don't want it to match in order to demonstrate what happens when it doesn't. And then pure x. So now it fails for the other reason that I did expect, which is that there is no monad fail instance for either, and that is good, because there used to be an implementation of fail, because there was an instance for every monad. So it was instance, it was inside of monad, not monad fail, but the instance for either anything. I guess I have to write it in one line, or use the syntax again. Fail is just error. And now, if I try it again, it will be accepted because now there is a monad fail instance, and we'll have the same behavior as we used to have before monad fail was introduced. Which is that we get an exception, and that was sad. And so I think it's a very good thing that we now have the monad fail type class in order to properly distinguish between types such as maybe and list, for which it is useful to, it should be allowed to write these kind of partial pattern match because it is semantically meaningful, it will do something useful, it will restrict the focus to those cases. And I wish that indeed I could rely on the compiler to tell me whether I am using these partial patterns correctly or not. That is, that I'm only using them for types like nothing and maybe for which it makes sense. But unfortunately, while I'm glad that we don't have a monad fail instance for either, alas, we do have a monad fail instance for IO, which does throw an exception, and so I can't rely on the compiler to tell me whether it is safe or not to use a partial instance. I must always be careful, because maybe I'm writing it in IO, or maybe in a monad transformer that delegates to IO. Like if I have a maybe T IO, who knows if it will do what I expect, which is to focus on the case that I want, or if it will throw an exception. And one particularly sneaky case is if I have except, like we have a semantic for backtracking, for not looking at a particular case, so it feels like it should be able to write except a string. It feels like I should be able to write a partial pattern in order to restrict my attention to the cases I care about, and to use the semantics of the monad in the other cases to backtrack or to return nothing or otherwise. But alas, this instance cannot exist. Well, it can exist for string, but like not for int. And so the concrete instance delegates to the base monad, and then it fails with an exception. So that's a case in which, like, I would have made a mistake. I mistakenly thought that XFT supported the semantic I like for restricting our attention to the pattern, but it does not, and the compiler doesn't catch my mistake. It just throws an exception. And so as a result, I'm very disappointed in when it failed, because it had this nice promise, but it doesn't deliver on it. The fact that there are now two classes of monads, those that do and do not implement when it fail, is not useful to me, because there doesn't seem to me to be like a meaningful distinction if those that do implement when it fail can do so by throwing an exception. I can see that the distinction is that in I/O we are throwing an I/O exception rather than returning bottom. I still don't find it very helpful. So sorry for this very long rant. It's just something that was on my mind recently. Alright, so we need to combine. This is going to produce a list of rules, so just set that from list. Should give us what we want. No, it doesn't. So what's the type of full parses? Oh, I see, because early that full parses returns one list of rules and one report. And so I should not be using bind here to iterate over all of the results that full parse returns, because it returns a single pair, a single tuple, and it's over the rules that I want to iterate. And the grammar, just need to include grammar. Ah, forms a cycle, no! Ah, that's unfortunate. Okay, no problem. I will just move this to the grammar. It's quite related, I think. Oh, parse words is already doing what I want. Here. Parse words on the input, which consists of words. That gives me a list of possible rules, so I can iterate over it to get a single rule. Test passed, excellent. So that means I should now be able, as a grand finale, to run the game, push the is to form a rule and demonstrate that Giggles is You has the magic. It has the quintessential Baba is You feature. It does! I am very happy with that. And I think that is a very opportune time to end the episode. I like to end on a high note, and this is a very high note indeed. I have, like, this is technically a Baba is You clone now. Excellent. Alright, so thank you very much, and see you next time. Ciao! Ciao!